All right, absolute value equations. Absolute value equations. Again, you're going to need notes kind of on your own notes today. And then today's assignment is from the book. So we do have a packet for this unit, but you don't even need it today. So I'm going to hold off giving it to you because I don't want you to get confused about what's in it and what's not, because what we need today is not in it. Let's start with some kind of warm-up stuff. Things that you already know. I think you already know. So 3 simple questions. I'd pause the video, but I bet you can answer them in the time it takes me to hit pause and unpause. Absolute value of negative 32. Absolute value of 32. And then if the absolute value of x is 32, so kind of thinking backwards here, what does x equal? Put Ryan on the spot for the hard one. Ryan with his 3-hump camel there. Cody, what's the absolute value of negative 32? It would just be 32. Of course it would. Logan, how about the absolute value of 32?
Negative 32.
Oh, absolute value turns things positive? So it would just be 32. Okay, Ryan, you have to think backwards. If the answer is 32, then what was the thing that was in parentheses?
32.
Is there anything else that could have been?
Negative 32.
Okay, absolute value turns things positive, which means the original could have been negative, could have been positive. We don't really know. This last statement here, this is sort of the heart of today's lesson right there. So that makes sense. We'll extend that and do some examples with it, but that's the basic concept that's going on. Sort of 2 definitions of absolute value.
The distance is 0 from the number.
Yep. 2 definitions of absolute value. So one of them is exactly what Jack say that? Ethan said that? Well, that was correct. The absolute value of x is the distance. Distance is always positive from x to 0. It's like, how far is it from 0? That's why if the answer is 5, then there could be 2 places that are 5 away from 0. I guess we should start with the other explanation. That's why the absolute value of 5 is 5, and the absolute value of negative 5 is 5, because they're both 5 away from 0. They're both 5 spots away from 0. The algebraic definition. I guess that one's more of a geometry kind of definition, a distance thing. The algebraic definition looks a lot worse, a little bit harder to figure out. It's piecewise defined. You hate the fancy little brackety thing? So, if x is greater than or equal to 0, then absolute value of x is just x. Right? If x is positive, then you don't have to do anything to it. One way to phrase that. And piecewise always feels a little backwards because the if part comes second, the then part comes first. Like, if x is greater than 0, then you use this formula. If x is less than 0, then you use this expression, negative x, meaning change the sign. That looks a little bit weird to some people because they're like, wait a minute, I thought it was always positive. Like, well, if your x is negative, and then you put a negative on your negative, what happens? Makes it positive. So this is the algebraic definition. This also fits with the graph. Right? If x is greater than 0, then you're just going to graph y equals x. If x is less than 0, then you graph y equals negative x. And the combination of those two things makes the absolute value.
Wouldn't it be x is less than or equal to?
Okay, that wouldn't be wrong, but then you wouldn't know, in some ways this would not be a function, because you wouldn't know if you plugged in 0 whether you use this one or this one. So that's a really good question. The question was, why not have an equal sign on this one? And I guess you could put it on either one, but you wouldn't put it on both. Because then, it would still land at the same point, but without seeing that, you wouldn't know where to put 0 in. Okay, but the main point of today is, that's like all background stuff that I think you've seen before, but maybe a refresher. The main point today is solving an absolute value equation. Solving an absolute value equation. And hey, the good news is you already did one of these, but that was the really easy one up there, the third little example that we saw. That was a pretty simple one. But we're going to take that same sort of thought process to a more complicated one. So I'm going to list the steps and work a problem at the same time. List the steps while working a problem, because I think that helps make sense of the steps, because sometimes you read the English, you're like, what exactly does that mean? And so as we go through the steps, we'll also go through this example problem. 3 times absolute value of x minus 2 plus 2 equals 14. So isolate the absolute value. So I'm going to get the absolute value thing by itself. So I'm going to get that highlighted chunk by itself. And so the first few steps, you don't really even have to worry about the absolute value part. Like, you're just doing things to get the yellow box by itself. So what could I do first to get the yellow box by itself? And then what would you do after that? Can I do that all at once? Some of you are like, oh, minus 2 would give me 12, divide by 3 would give me 4. 2 steps at once. I'll try not to do more than 2 steps at once, because then I might mess up. But I think you guys can handle 2 steps, as simple as minus 2 divided by 12. Okay, so we've got the absolute value thing by itself. The next step is where we're going to split it up. You're going to solve 2 equations. You're going to set, let's see how to phrase this the best. Well, think about what we did earlier when it was a simple one. It was x was either 32 or negative 32. So what do you think that means for this problem? You know what, let me cover that up. If the absolute value of something is 4, what does that mean? What could be under my finger right there? 4 or negative 4. So that's how we're going to split this into 2 pieces. So let's write it out. You're going to set the inside stuff equal to the positive answer, and the inside stuff equal to the negative answer. So x minus 2 is either 4, or x minus 2 is equal to negative 4.
You wrote inside what? Yeah.
Yes, because you take the inside stuff and set it equal to 4, and take the inside stuff and set it equal to negative 4. And officially there's an or in between there because the answer could be either one of those choices. So x equals 6 or x equals -2. And then lastly, check your answers. Nicole, you okay?
Wait, how are you negative or positive?
Because whatever's under that popsicle stick right there is either 4 or -4, right? Like you don't know what it is, but if the absolute value of something is 4, then whatever's under there is either 4 or -4. So you just set the insides equal to the plus and minus, and there's your two answers. Now, sometimes this is one of those places in math where you can do everything right and still get answers that don't work. Do you remember the fancy name for those type of solutions? Answers you get that are, you didn't do anything wrong, but they don't really work. You're on the right track.
No real number.
If it doesn't work, it's called, it starts with an E. Extraneous solutions. Never use that term? Okay. Extraneous solutions means you didn't do anything wrong, but it still didn't work. And it happens it happens most frequently with dealing with negative stuff. So like when you square both sides, sometimes things get messed up. When you're dealing with absolute values, sometimes things get messed up. Again, it's not that you made a mistake, it's just that the negative stuff doesn't always work out right. So let's check these answers back into the original. And checking is usually pretty quick. 6 minus 2 is 4, times 3 is 12, 12 plus 2 is 14. Yep, that one worked. Checking the negative sometimes messes people up. So one thing at a time here. -2 minus 2 is?
-4.
Absolute value of -4 is 4. And then 12 plus 2 is 14. So they both work. Again, this is not checking because you're a conscientious student and you just want to make sure you got it right. You're checking because you can do everything right and still get answers that don't really work.
When we put it
If it doesn't work, you would mark out whichever one or ones don't work. So if one of them doesn't work, you'd still have an answer. But if two of them don't work, you would have no answers and you would just say no solution. I guess if that was example 1, we can call this one example 2. -2, absolute value of x minus 4 equals -10. All right, what do you want to do first? Yes, so what should we do to isolate the absolute value? Divide by -2. So, absolute value of x minus 4 is 5. And then, now we do the split up thing to get rid of the absolute value. So it's either, well, you guys are jumping ahead, which is okay, but things get more complicated later. So let's show this step, even though you're right, that gives you 9. What's the other step? X minus 4 is 5, or?
-5.
X minus 4 is -5. So yeah, x equals 9, or x equals, a little harder on that one, -1. But then we have to check them. So -2 times, yeah, that one works. Again, in checking, show as much work as you need to. Because if you don't check and one's wrong, then obviously you'll get that problem wrong. Negative 2 times absolute value of negative 5 equals negative 10. So that would be, so does this work or not?
Yeah, it should, because
Yep. Because you get a positive. But some people, their brain is so used to saying, multiply two negatives, you get a positive. Well, yeah, but you got to do the absolute value thing first. Negative 2 times 5 is negative 10. So they both work, so we're good with that. Guess we probably need to see one that doesn't work. Convince you that you really do need to check. 5 times absolute value of 3x plus 1 minus 20x equals 10. What do you want to do first? Well, yeah, you give me the answer I told you earlier. Isolate the absolute value. So we're going to get that thing by itself. So let's move the 20x over. So 20x plus 10. Divide by 5. Okay, now we got to set up the two separate equations here. Well, the first one's easy, right? 3x plus 1 equals 4x plus 2. Got it. What's the other one? 3x plus 1 equals?
negative 4x minus 3.
Okay, I'm going to do one step prior to that, but you were right. Negative, whatever's on the other side. So negative 4x plus 2. The split up step takes it from one impossible problem to two hopefully easy problems. That's sort of the key step for today. Equals the positive one, that's the easy one, just drop the absolute value bars, and then set it equal to the negative answer for the other one. Okay, so I subtract 3x from both sides, and I get x. I subtract 2 from both sides. Oh, Jack! I shouldn't pick on you like this. What's 1 minus 2?
Wait, where? 1 minus... Oh. Negative 1.
It is. It sure is.
I don't know.
So x equals negative 1 for that first one. On the other side, let's see. Some of you distributed the negative right away, which is fine. I'm going to add 4x to both sides and get 7x. Subtract 1 from both sides, get negative 3. So negative 3/7. You're suspicious of that one? Okay, well, let's plug them in and see what happens. So we got to do the check thing here. And when you check, always check them all the way back into the original. So 3 times negative 1 plus 1 minus 20 times negative 1 is supposed to equal 10. Well, I said checking's easy, and I guess it still is, but that's a lot of stuff going on here. Negative 3 plus 1 is negative 2, but the absolute value of negative 2 is positive 2. Wait a minute. 10 plus 20 equals 10. That's not true. 30 equals 10. No, 30 does not equal 10. So that means x does not equal negative 1. That was an extraneous solution. We didn't do anything wrong, and yet it still didn't work. All right, let's plug in negative 3/7. This is the one you were suspicious of.
So maybe 1 minus 2 is If you did it that way, it might have worked.
Three times negative 3/7. This is going to be yuck. Minus 20 times negative 3/7 equals 10. Oh, we get some more fraction practice here. Some of us need it. When multiplying fractions, please do not multiply the top and bottom by 3, because that would not really be multiplying by 3. That'd be multiplying by 1. Yep. So negative 9/7 plus 1. 1 is the same thing as 7/7. So that would be 2/7. Well, negative 2/7 on the inside, but then 2/7 when you absolute value it. 5 times 2/7, which would be 10/7, and this is still supposed to equal 10 somehow. Plus, what's 20 times 3/7? 67. Oh, this works out.
Wow.
Right? 77. I mean, I may not be great at fractions, but I know what 77 is. That's 10. So that one did work out. So this was a great example because the one that looked ugly and that you were maybe rightly suspicious of is the one that worked. And the one that looked like, hey, that was probably right, didn't work. So you got to check your answers because sometimes they work and sometimes they don't. All right, one more example, and then we'll be done. Last example. 3 times absolute value x minus 2 plus 10 equals 4. You know what? Since it's our last example, why don't you try it?
You saw that
So there is a bit of a shortcut to this one if you're really paying attention. And some of you kind of caught it. When could you have known that this wasn't going to work?
when it became a negative 6, right? The answer would turn negative.
I would say for sure when you get here, maybe one step before that, but be careful. If you have absolute value equals a negative number, that can't be right. So if you get there, then you can skip ahead and say, wait a minute, that's not going to work. No solution. Now the trick is, if that's the 5th problem of a bunch of absolute value problems, then a lot of times students don't see that. They're just process, set it up, do the thing, check it, and that's fine. You still get no solution. But man, if your brain is engaged and you catch that, you save yourself a little bit of time and realize, wait a minute, that's not going to work. So, as always, work math problems with your brain turned on. Things go a little bit better for you. All right, today's assignment, and we have 10 minutes, so you've got at least enough time to get started, maybe even finish, because it's easy. This one you'll need to do on paper, your own paper. Page 30, 25 to 41 odd, 47 and 49. Okay, well then go grab one and take a picture of it. Then you have access.
I'm doing this on the back of my notes. That's fine.